All right. So I want to welcome everyone for joining the Tech Talk today, Attacker's Journey Part 3. Monty couldn't join as the host, unfortunately, because he is traveling and couldn't join us today. But on the call, we have two great personalities in the space. First and foremost, on our side, we have Noah King. He's one of the founding engineers at Horizon 3. His focus is on, full stack web applications. And when I say full stack, I do not take it lightly. It's very rare that you actually get somebody who really does the full stack of it. But his specialty is SaaS-based full stack web applications. He has an expertise in JavaScript. He's been teaching beginners. He teaches classes, mentors, a bunch of boot camps. And I know that personally, he's been a mentor to me as well in my hack the box journey. So it should be really interesting to see how he goes through today's challenge. And then Jake, of course, the offensive security consultant at Echelon Risk and Cyber. He's experienced in both building as well as breaking down web applications. So a worthy adversary. He's worked in Pittsburgh-based companies, like Carnegie Mellon's computer emergency response team. So, you all know CERT. He has a lot of work in bug bounty programs. So I'm really interested to hear your perspective on the topic of the day, which is Ssrf. So as just a quick introduction to myself, I am Brad Hong. I am a customer success lead here under Monty at Horizon 3. For me, my experience really sits on understanding how certain vulnerabilities take part in affecting business operations and business continuity. Making sure that for me an ROI is the type of risk that vulnerabilities pose. So it's reputational, it's operational, and then it's informational or intellectual property. And what's really interesting about today's topic with server-side request forgery is that there's so many different channels in which this can be a dangerous vulnerability. At a high level, it's a web security vulnerability that essentially allows an attacker to induce the server-side application to make requests to an unintended location. That's the simplest way I would describe it. But what's really interesting is the plethora of different ways in which an attacker can take this vulnerability and do a number of different things. So I think for me, it was probably one of the scariest vulnerabilities, just because it's so complex for the day-to-day person to truly encapsulate and understand what's going on. But then also, then to make sure that it's locked down in multiple different ways, whether it's the port scans, whether it's the actual coercion of, the credentials and all that. So with that said, I'm going to pass it over to these two guys so that they can, take you through their own adventures of the forensics, of the investigation, and then really figuring out how to use the vulnerability as an ethical hacker. So I'll pass to you guys.
Yeah, thank you, Brad. Appreciate that intro. So welcome, everybody. Like Brad said, my name is Noah King. A lot of experience on the full stack web app side. And Jake, it's great to have you back. Last time we were here, we were covering SQL injections and had a lot of fun with that. So now we're jumping into server-side request forgery. So
yeah, thanks, Noah. It's good to be back.
Yeah, absolutely. So I think the first thing that we should do, let's just kind of, have a quick conversation, talk some question and answer type thing. And then we'll get into a demo where we're actually going to exploit and show you how to do a server-side request forgery attack. But Jake, why don't you tell me, in your opinion, why do we care about server-side request forgery? What is it, and why should we care?
Yeah, I think, excuse me, I'm fighting off a cold here, so I'll do my best to limit the coughing.
Sure.
But why should we care about Ssrf? I'd say in general, it's a less common vulnerability. In web app tests we do over at Echelon, I'd say 1 out of 10 tests, we find this. So, why care? It's because it can have a pretty high severity. And if you look at the Capital One breach of the past, I think that was a few years ago, and it resulted in, I believe, over $100 million of data and problems for Capital One.
Mm-hmm.
So it's a vulnerability that can have a very high impact if it's in attacker's hands.
Yeah, absolutely. When I was doing the research and looking through Ssrf, the first thing that I saw was this Capital One story. And I have a couple of notes here. 106 million users across the US and Canada were exploited. Their data was breached. And, we're all kind of Capital One customers, or, a lot of people are, and it's a large bank. And so it seems like it's a very nasty vulnerability when it does come up in the wild and people are able to use it to get to new data. The way that I view server-side request forgery when I've been doing this research is I almost view it as it's like the escort. When I have a web app and I find that it's vulnerable to server-side request forgery, it is escorting me into that network and bypassing firewalls, bypassing other controls, because now I'm making these requests on behalf of the server that they own. And once you have that, you have power, you have access to things that you wouldn't normally have access. So fun fact with the Capital One thing, when I was looking at it, it looked like a lot of that too was around EC2 metadata exposure, different applications and finding ways in. So we're really going to demo that too. We'll try to give you a little bit of a realistic glimpse at what Capital One's server-side request forgery might have looked like. Other than that, just Jake, in general, it seems like too, from my research, like bug bounties, a lot of companies are also paying lots of money if they are vulnerable to this. Can you maybe explain why do they pay so much money and everything for these?
Yeah, so usually with Ssrfs, the severity ranges from low or minimal to kind of the higher critical range. And on the low range would be more blind Ssrf, where basically you're issuing a GET request on behalf of the server. So as an attacker, you'd be able to view that request was actually going through, and you can see the IP address of the server issuing it. Now, obviously, that's not too sensitive of information, but kind of, on the other hand, the high critical severity findings oftentimes result in some level of file inclusion. So like you said before, if you're able to hit a metadata server and get information out of that, and pull AWS access keys, as an attacker, you can take those and escalate your privileges or gain access to extremely sensitive information.
Yeah, and I saw it totally branches out. It's not just an HTTP GET request. We could use the file URL protocol. We could be calling into a Redis cache behind the scenes, trying to make some kind of update or post request to update that data. Gopher is another popular one. There's a lot of different protocols that we can utilize, FTP, all those things. So it really depends too on the technologies that you use. For example, from what I've read, Python, the URL lib, that's an example where it can pull multiple protocols, but then maybe you have an NPM package on Node.js and it's just doing HTTP protocols. So the severity, the scope can change based on infrastructure, code base, web application type, and all of that.
And a lot of times with these, as an attacker, you have to be creative. And like you said, depending on what wrappers the server allows, whether it's Gopher, file, just a normal HTTP, HTTPS, the attack path can vary. So it's a really interesting vulnerability and how different it can be. And if you're able to be creative and have that mindset, you can come in, potentially even escalate it to an RCE. So it's a really cool finding.
Yeah, I think go ahead, Brad.
I was going to say, I think this is exactly why, to me, the Ssrf vulnerability is a pretty scary one, because it could be used either for reconnaissance, right? Figuring out what ports, what services are running, but then ultimately escalating yourself to a point where you're picking up credentials and, like you said, RCE. And honestly, the irony is not lost on me that even in the Capital One attack, though the vulnerability, right, the first foot in the door was via Ssrf, it ended up being a credentialed attack, right? They walked in with the credentials that they picked up from this vulnerability, and they just said, "Hey, I'm here. This is me," which is, it's kind of crazy to me.
Yeah, well, I mean, they always go back to that point of like attackers don't always hack in; they just log in. And
exactly.
the Ssrf here in this point was part of the kill chain. That was our foothold, our way into the door, into your network. And what's crazy, if you really think about it, again, it's only one path. You might have a web app that has 100 different routes that it exposes, or 100 different features that all go down 100 different code paths. And 99 are, protected, they're solid. But then you have one new feature, you got a new developer that onboards, doesn't understand how to keep their code safe, defensive, or how to spot these things. A lot of times developers don't even realize when they're writing this code, you're writing an Ssrf vulnerable app as we speak. And it's also about educating the developers, the practitioners. How do we defend against this? So when you're going and you're looking for Ssrf in the wild, you're in your thing, Jake, you're hacking people and you're looking for opportunities to get a foothold. What do you look for as far as Ssrf? Like, what's your go-to approach to find it?
Yeah, so one of my go-to tricks is I look for the word import. And that's not to say I look for it in Burp Suite requests, but I look for it more in the user interface. So if I see something like import a photo for your profile picture, import an article for a blog, anything along those lines, when you're importing something, chances are it's going to be either locally or externally. And you're going to be more often than not taking user input for that. So that's kind of a big giveaway for me to take a look closer at that feature and see if it actually is taking in that user input and if you can manipulate it. So that's kind of one side of it. I'm looking for any kind of importing. And the other side that I've found more recently is I'm looking for any place in the application that has a HTML to PDF feature, or even just an export to PDF feature. The reason being, a lot of times applications today will take user data, put it into HTML code, and then render it within the PDF. And the tricky thing is that rendering is occurring server side. Rather, the server is actually rendering the HTML. So, when that's happening, you can actually supply that HTML so that it can reach out as the server to an external resource. So I'd say those two things are key focus areas if you're in a test and you see them, definitely spend some time with them.
Yeah, it seems like when I've just been looking at different pathways in, when I'm looking at a web app, anything that says, hey, give us a URL and we will go scan it. I remember working at prior companies where we had features that said, give us a URL. We'll go look it up. We'll take a screenshot of it and then we'll render it in our app. And then you can do something with that tool. And that seems like a prime example of I'm supplying a URL. Maybe instead of giving you mywebsite.com, I say localhost port 3000, go after yourself. And so it's so simple, looking for different pathways in. So yeah, that's interesting. Yeah, awesome. So how do we mitigate it then? That's another question. So we come across it and we can see that it's, an impact. What are some of the ways that you think we should be defensive or spot it or protect against it?
So from an attacker's perspective, I always find it tough to attack applications that whitelist certain URLs. So, say you're importing something from Google. I know that's not exactly probably what you do, but for the sake of an example, let's say you're importing from Google, whitelist google.com, right? And all of a sudden I can't put in localhost, I can't put in, attacker.com, it's only that whitelist that's acceptable. So that's, what I'd recommend if you're going to do a server-side request, if that's if it has to happen through development. But otherwise, what I'd recommend is issuing a request on the client side through JavaScript. That way you kind of don't have to deal with operating in the context of the server.
Yeah, absolutely. Yeah, there's a lot of different things we can go down as far as defenses. It really also depends on your web applications and everything.
Yeah.
But I think the big thing that we want to at least provide today is a glimpse into how these exploits work, let you see the code. A lot of times when you look at the code, it's not very clear to always a developer or someone this is vulnerable. So I guess I'll go ahead. I'll share my screen here. So let me make sure I select the right screen as usual. There we go. And first thing I wanted to at least bring up, right? As I was doing research on Ssrf, I came across this image on OWASP. And if you're not aware, Ssrf is on the OWASP top 10. And I thought that this really highlights the attack path. So let's imagine you are this hacker right over here with your computer. And here's your vulnerable website in the center. So you're logging in, you're interfacing with this. Now, behind the scenes, we have a whole firewall. We can't just reach out to localhost. We can't reach inside their network. So instead, what I'm going to use is I'm going to use this website as my escort throughout your network. It's going to do the work for me. And do you find oftentimes that a lot of times when there's server-side request forgery going through a website like this, it's less likely to be detected from a defense perspective? Because
definitely you're going through an authorized resource, right? Yeah. Web server's already in the network, internal network. So if you can send traffic from that, all the better as an attacker, right?
Yeah. So I mean, we have trust. This is a trusted website running, and it's running on some server back here in this network. Now, what else lives on people's networks, right? Well, they might have loot, such as money. There might be something monetarily. It could be PII, private information that we could take. It could be files, users, analytics, data. A lot of times it seems like server-side request forgery, it might be your pathway in. It might be a way to gain more knowledge about that network, to find other systems that might be running that you're not aware of, such as third-party systems or different servers on that network. So overall, this is kind of, the way that I see it and break it down. Jake, I don't know if there's anything you want to kind of add, just looking at this overall breakdown.
Yeah, I think you covered it pretty well. As an attacker, I'm going to be trying to see how I can leverage a vulnerability. And I think Ssrf in particular is a great way to escalate your privileges. So say you're able to actually issue a request from the server. It's kind of like big deal, right? What can you do with it? But like you said, you have loot, you have possible PII. That's kind of what we're really after, from an adversarial mindset. So it just shows how severe this vulnerability can become if leveraged correctly.
Yeah. And I think the thing you have to think about too, from the attacker's perspective, right? They are always thinking creatively and outside of the box. How can I break your application? A lot of times I feel like developers, they're always in the mindset of, let me get it working. I wrote it, it works. And then they don't always either test their applications enough. They don't think about the impact, what else is connected, what else is running on the server, what privileges do we give it? And a lot of times those things get forgotten because of the pace that companies will often operate at. They always want new features. They always want new things. And sometimes testing or security becomes an afterthought for a lot of developers or a lot of people. So that's kind of what we want to at least cover and show you more of. Now I have this this website that I put together. So let's go ahead. Let's jump into the demo a little bit. I got this website that's running, fictitious company called Contoso, and somehow I stumbled upon their retirement app, right? So let's say I've identified Contoso as my target. I want to get on their network. I want to steal data. I want to do whatever I can. I want to make some kind of impact. And a lot of times what people do is you have public applications, you got all different web apps, and I see it a lot of times as the foot in the door. So I'm on this web app, it's running, and it's, employee retirement saving app. Now they have this feature right here, and you can always talk about different features and their securities. Sign up. I have that opportunity to go ahead and just sign up. Now I've already went through actually signing up. I have just a dummy user here, and then I got a password. And it's pretty common once you're logged in, either authenticated or unauthenticated, that you could be vulnerable anywhere, any kind of feature. Anytime there's an ability to type something in and give feedback, that might be an opportunity. Now, the one that I know that is server-side vulnerable is the stock market research. Let's just say I put in Apple, right? I'm searching for the Apple stock. I click on it, and the first thing I noticed is it redirected me to Yahoo, and it's showing me all the stock information right now on Apple. If you look in the URL though, Jake, I'm sure you kind of noticed it right away.
Yeah.
The URL is hard coded right up in there.
So it didn't actually redirect you. It kind of just included that finance.yahoo within the code. So that's kind of like a dead giveaway. We have a remote file inclusion here due to Ssrf.
Yeah. So then the first thing that I thought I would try is let's just manipulate the URL. We're not even using any advanced tools. This doesn't require a lot of advanced knowledge. You could have somebody with low knowledge level to come in and try these things. Now for mine, they have this little ticker symbol, Apple, little URL parameter. So I'm kind of going to chain them together because I know after researching and exploiting it a few times, I'm going to concatenate these two URLs and variables together. So we're just going to try to go to this URL ifconfig.pro. And if I hit enter, the following is the stock information you requested. So that's kind of some feedback that I'm searching a stock for Contoso. But now what's being rendered on the page is all the if config or if config of this. And this is at least one way for me to kind of verify. Jake, are there common URLs that you like to use, or what's your first approach?
My favorite thing to do is, I actually have two things I like to do. First, if you have a Burp Suite Pro license, you can use the Burp Collaborator. You basically plug in a Burp Suite generated URL, and it'll tell you if it gets a hit. So like I said before, you need a Burp Suite Pro license to do that. If you want to go the cheaper route, you can go on DigitalOcean and create an instance on there. Last I checked, it was like $5 a month. And you can have spin up your own IP address and then listen on, say, port 80 if you want, or whatever. And then you can put in that IP address, and you can see actually whenever it kind of gets a connection. And at that point, it's vulnerable to Ssrf, and you can see data like the IP address, user agent, or any other headers that are included.
Yeah, absolutely. So let's go into Burp. So you brought up Burp. I'm gonna go to this website. I went into Burp Suite, which is one of my favorite tools that I've really enjoyed working with. And I'm just gonna go ahead and turn on my intercept here in a second. Let me just kind of make sure I'm logged in. And I know that this was that URL, Apple. So let me turn on, let's see, where's the little Burp Suite? I always lose it. Intercept. And then let's send that request again, submit. Right when we do that, we have that network request. I've captured it, I can manipulate it, I can try so many different things. At least the approach that I took, and that, Jake, I'll have to try some of your approaches as well, because I wasn't aware of that one. But first step is just go to repeater, and here, you can type in the URL, you can see if it brings back HTML, you can render the page. Burp Suite's a really powerful tool. So for me, I just come in here and then I start playing around, trying different URLs. And the one that we did was ifconfig.pro. And so we have that. And let's take it a step farther now. So we've verified right? That we can server-side request forge this application. Some of the things that I might want to try as an attacker, what is your next step, Jake? If you know that you can do this, where are you going next?
So from here, I'd be interested to see if we can access localhost there. So instead of ifconfig.pro, http://localhost, let's see if we can get port 80.
Okay. Yeah.
The reason being, if we're able to access localhost here, we can port scan it, see what services are running locally. And then from there, we know we're operating the right context. We could try to reach out to other infrastructure in the network. Looks like you need a dot after that second zero.
Ah, yeah. Thank you.
Yeah.
All right. So let's see. I think I don't have anything running on port 80 on this one, but you talked about port scanning it. So this brings up a good thing. Let's go into the port scan method. At least my approach, what I've tried is I'll send it to the intruder, which I really love the intruder. If you're on the more pro, you can send a lot more requests at once. The free trial seems to be a little slower as far as throttling you. So definitely recommend a pro trial. So I'm going to add one variable. Go after this port number. Go to localhost 127.0.0.1 port number. And so we have 4,000 here. I'm going to go into here. And I think I can say instead of a list, let's give it numbers. Let's go from port 80 all the way up to port 5,000, 65,000 some ports. We could go after them all if we want, but just for the sake of the demo, we'll stick with that. We'll take one numerical step for each one. So 80, 81, all the way through 5,000. And I think that should be enough for me to at least kick off this attack. And so now this is running. You can already see I'm firing off thousands of requests, almost 5,000 in total. So we'll sit here, we'll wait. Is this kind of like the common approach? Do you throw it in Burp Suite or do you use some other command line tool?
Oh, definitely. Burp Suite Intruder is one of my go-tos. I said it before, if you don't have that Burp Pro license, you can actually, within Burp Suite, export it as a curl request, export the request you're messing with as a curl request. And then if you Google burp curl to Python script, there's a website that'll come up that will actually transform it into a Python script. So if you're trying to save that money, because I've been there, I was in college doing this, you can write your own Python script and it's way faster than the free version.
Yeah. So, tools are expensive sometimes and everything, but I really have enjoyed Burp Suite Pro when I got the license. Now, this attack is finished, right? And sometimes it's a little hard to decipher what is good, what is bad. This server is bringing back all 200 responses, but there's nothing here. But I sorted it by the content response length. And I said, all right, well, let's see what had a longer length than just kind of this HTML response. Looks like 4312, 4,000 are both open. 4312, I got some kind of response, internal Contoso retirement backend API. That is an indicator to me, that might be something there running on localhost on the internal network that's not exposed. So we might go for that here in a minute. If we look at 4,000, that's where the app is actually running, this Contoso web app. This is running on port 4,000. So we have a new target that we can go after, 4312. Before we do that, before we go to that target, let's talk about some other approaches. I think in standard approach, a lot of times these web apps, different things, they're deployed to the cloud, and it might be on AWS, Azure, Linode, any of the different cloud providers. Do you also then try to go after, let me just see if it's an EC2. Let me see if I can grab metadata about this server. Let me, try some of those low-hanging fruit just in case it's there. Is that one of your approaches as well?
So usually I start locally and I work my way out. So I'll typically do, see if I can access localhost on port 80, because that's the usual one. But like you said, this is running on 4,000. So I'll begin with a port scan. And then from there, if we have data, I'll enumerate that. I'll write it down into a document. and then I'll try the metadata server. And so
Okay.
you mentioned, cloud tests in general. So AWS has a metadata server that you can reach out to just with a GET request. No extra headers are necessary. I think it's worth noting that GCP and Azure, last I checked, require an additional header in the request. So if you're trying to reach out and hit those metadata servers, you have to have a little more control over the request than just kind of the host you're hitting. Does that make sense?
It does. Yeah,
Okay.
that absolutely makes sense. So sometimes you have to be aware of what you're trying to go after, and
Yeah.
you might have to supply additional arguments, additional headers, things like that. Let's try to go for this metadata. So again, since we have this URL parameter, the symbol, Apple, Tesla, whatever, I'm going to have to feed that in, and we'll look at the code too and see how it's vulnerable. But AWS EC2 metadata, it's always on this IP. 169.254, 169.254. Get me the latest metadata. Let's send that request. Let's see what we get back. The following is the stocking. Let's go into more of a raw response. Right here, I can already see I have some kind of response. AMI ID, host name, IAM, tags, profile. It looks like I'm getting metadata back. And so now I just keep chaining it, going after it. Are there certain ones in general you like to go after? Like, really, these are the sweet ones to go for?
Oh yeah, my favorite is, you see IAM there.
Okay.
Within there, I believe, is the security credentials.
Yeah, so let's go.
And that's kind of where your access, there it is, yeah. That's where your access keys are going to be for AWS. And that's kind of like a prime target for us as attackers.
Yeah.
So you see that's your user, your EC2 Contoso.
Yep.
Whenever you load that in, send it through, bam, there's our access keys.
Yep.
And so you see they start with ASIA, so they're temporary access keys, which means they expire at some point. But if you use the key ID, the secret, and that token there, you can actually plug that into the AWS command line, and you can essentially log in with just that, AWS.
Yeah, it seems like you can just say, AWS, let's configure this. And then I just start taking these keys. So the access key, grab this, copy and paste it. Now mine aren't set up to work. So if you get my keys, they're not going to work. But I would plug them in as an attacker, and I would go through this, and now I can interact with the command line. I can say AWS EC2. What can we do from there? There's all these different things we can go after. There's a lot of different command line interfaces. Get me stuff, cancel, all of that. Are there certain ones in here you normally like to go after?
So my favorite thing to do, and I'm glad you asked, is there's a script available on GitHub. It's called enumerate-IAM. If you run it with the access key and secret specified, it'll actually tell you what all you can access with those keys. So it makes your search a lot easier. And oftentimes, permissions on keys are overdone. So you'll find that you're able to access, for example, a S3 bucket with a ton of data, or an EC2 instance you shouldn't have access to. But kind of knowing what you can access starts with that enumerate IAM script. Oh yeah, you pulled it up.
Yeah,
there.
this one right here.
Perfect.
Yes.
Yeah.
So that's also the beauty of open source security and sharing things. Not only is it something that an attacker might be able to use, but at least it allows us to also try to audit these things, repair them, prevent them, and test our own environment. So you would grab this script, you would enumerate what are your permissions, what can I do with this key, and then go from there. Yep, awesome. Okay, so we grabbed some of that metadata information. Let's go back to this repeater. So we grab secret keys. That's a pretty nasty one right there. I can pivot. I can go down different, attack chains. I might be able to chain this attack and keep going. Some of the other ones that I was looking at and researching, other than the security credentials, let's see, I have one here. Let's get the metadata. It would be the user data. You can also go after user data. Is that a common one for you too, Jake?
Yeah, I'd say that's the second one we hit. the main focus is those security creds, but we target the user data too.
Yeah. So when I was doing some research and I was looking at the user data, I think that's correct. Let's see if that works. I read on Stack Overflow, I've read different developers giving bad best practice advice. So even though you see that green check on Stack Overflow, hey, do it this way, it doesn't mean it's the most secure way. And from what I saw and gathered, a lot of people love to store environment variables in their user data as a way to pass those in, such as the DB username is root, go put it in the Etsy profile, or the DB password, super secret password. I might be able to get into your database. I might be able to do something with this as well. So it's more opportunity. It's more information we can collect and move on with. Jake, anything you want to add?
I'd say oftentimes if the admin's doing something like this, like storing environment variables in this way, chances are the access keys are over permissioned. So usually if you're making mistakes in one area cloud, there's issues in the other. So this would kind of be a gold pot for us as an attacker. Clearly we have the clear text DB password. So it's important to configure things correctly, I'd say.
Yeah, I think
Jake, you mentioned early on about blind or out of band Ssrf vulnerabilities. In the beginning, when Noah was kicking off his Burp Suite, I think you mentioned you would instead force the application to make the DNS or the HTTP request to like a server, or rather a device that you're hosting. Would you say that would solve that problem? Would you still then be able to, without a response from that request, still be able to identify the vulnerability of that application?
So blind Ssrf, which I believe is what you're referencing, is a lot less severe than something like this. And the difference between this and blind is with blind, you can't read the response. So we wouldn't be able to see the DB connection, username, and password. So usually we give blind Ssrf a low severity. Chances are with it, you're only going to be able to see the internal web server IP address along with, a header, if there's a sensitive header there included. And the third, and usually most important thing you could see is a user agent. So say they're using something like Phantom.js to actually make the request, we're able to see that. And, as long as it's up to date, it's not too big of an issue. But if there's a vulnerability in Phantom.js, all of a sudden, the attacker knows the version. They can kind of continue along that mindset, having the version.
Yeah.
So it's definitely, it's not a, something to completely write off those low severity vulns, but it just depends on the situation, I'd say.
Yeah. So adding to that, is that's kind of one of the headers you're kind of implying, like X powered by, I now know it's powered by Express. We're going after a Node.js app that's running Express.
Exactly.
And then that gives me more info. Let me go look up if Express has any exploits, any vulnerabilities, anything I can maybe do there. It's just, there are more pieces of information that might give me something to get to. But yeah, that's a good point, Brad. And thank you for the blind information as well. So, all right, so we've grabbed user data, and we can do a lot of things with the EC2 metadata and all these different things. But let's go back to that port that we were doing, all those port scans. In my notes, I know that port, when we were running it, was vulnerable on 4312. That's the port that we found. I'm going to send this request again to the intruder. And then I'm just going to clear out what I want to use intruder for. And let me see here. We're going after 4312. So I'm just going to change this to 127.001. And then we know that's port 4312. And then let's just throw a slash in. Let's see if we have a response, or we should.
And something I'd like to mention, Noah, is sometimes you'll see firewalls blocking, 127.0.0.1, where they'll block just local host, and they'll think, that's sufficient. But there's a lot of different ways to bypass, or not to bypass, but rather to specify local host. So you can do just 0, you could do 0.0.0.0.0, or you could even do, I believe it's 127.1, and all are actually acceptable and will still hit that local host. So it's a little trick to keep in the back of your mind if you're dealing with a firewall there.
Yeah, that's good to know. A lot of times I see in people's code, they'll say, if the request URL is equal to 127.0.0.1 or just localhost, and developers kind of stop there. They don't know or always realize attackers have different ways to kind of skirt around that protective if block in the code. So yeah, that's a good point. I appreciate you sharing that one. Yeah, because a lot of times it comes down to what are you blocking? So I have this request, and if I set it up correctly, we'll see here in a second, I'm going to load in a list of things that I want to go after. Now I have this directory list. It's just a word list of common, /admin/sign-in, all the different possible routes that we can maybe hit up and get a response from the backend. So I'm going to load up this list. Sometimes these word lists are pretty large. We're only going to keep it to 1,000 items. And I grabbed one of the first ones I saw on the web that's popular. I put together an API that's vulnerable, used a common word, and it was in the list. So is there, in general, do you ever feel like people should go about it like naming their endpoints slightly different? Like a lot of times, like what if it's just admin? What's your thoughts on that?
I think the way I look at it is it should be coded securely so that even if they find it, there's nothing you can do. I always, what do they call it? I think it's security by obscurity. It's never a good idea, right? It's always better to have your code tested to make sure it's safe and an attacker can't kind of break into it to begin with. So that's kind of where I fall in the matter.
Yeah, absolutely. Yeah, because I think that's sometimes the common approach people think of. They're like, oh, well, the word admin, I won't use that word, or let me say just a bunch of gibberish strings. But then that also creates complexity for the developers. What does this route go to? How do I map that? It can be a challenge. So that's good feedback. So, all right, while you were explaining that, I kicked off this attack. It's only 1,000 requests. And if you kind of look at it, you can see that the URL that we're doing requests to is common words. Go to research, go to the localhost port 4312/AAA/Kansas, Colorado, Alaska, admin, SSA. There's a bunch of random words that people might be using, and we're just trying to see if we can get some kind of response back, something. Now mine is bringing back all 200. So I have to, again, be creative in how I filter this out. I'm going to filter by content length. And the first one that I see at the top, employees, it has a length of 3,200. Let's take a look at that one. So if we open this one up, we expand it a little bit, it looks like I have some kind of information here. It says ID, first name, last name, email, username, 401k balance, stock market. And it looks like I'm pulling back users. I got a list of users here. First name, Sutton Holcroft. There's their email. There's their username. There's their 401k balance. So that's a lot of PII that I just was able to find from a simple Ssrf. Jake or Brad, like, any thoughts, feedback? I mean, clearly this is a lot of reputational impact. This could be shared out on dark web and sold on the marketplace.
Yeah, it's a great find. I think it's important to stress too that in order to find this and retrieve that data, this API was actually running locally. So it was inaccessible to the external internet. But because we found an Ssrf, we were able to issue requests as the server. And because of that, we could access this local service. So, if we were just trying to reach the server externally, we wouldn't have been able to find this endpoint.
Yeah. So like if you you talk about that. So if I go to port 4000, that's where the app is running. If I could type it in correctly, let me try that again. Perks of live demos. Let's see if that works. There you go. So there's that web app, and it was running on port 4312. If I try to access that, I get nothing. I get no response. So it's not available to, the front end is not exposed outside of this network. But from doing those port scans, using Ssrf, going through the research and everything, we can reach very deeply into your network, all through just one GET request. Or we can, enumerate the backend. We can enumerate your ports, APIs. The options become limitless from here. So yeah, that's good feedback. Brad, what do you think about this in general? If you're a company and you have this type of breach, how much kind of impact, brand reputation, cost would this cause a company?
So, the couple different things here. Off the bat, I think if you ask a group of 100 IT or information security folks, how often do you guys research new attack tools? Guarantee you'll get maybe one or two to raise their hand. But if you ask the opposite, right, 100 offensive, right, or 100 attackers, how often do you research defense tactics? Every single one of them will raise their hand, right? And so, like you guys said, I think it's sort of a misconception to say a hacker attacks just to get money. For them, every single bit of data is important to them. And this instance here, reputation is one thing, but guess what? Capital One, they're going to be okay if they don't have to, or if they have a little bit of a tarnish in their reputation. But when it comes to an operational standpoint, even intellectual, right, what they're doing, how they're situating portfolios, stuff like that, that's going to be a bigger problem for them. It's going to be the compliance people, the regulatory people who come in and say, hey, you owe us money now because you breached NYSFS, DFS. And so for attacks like this, it's pretty wide scoped, right? It goes way beyond just the one thing or another. It's one of the few vulnerabilities that I think can address or even attack all three sections that I mentioned earlier: reputation, operation, and intellectual at the end of the day.
Mm-hmm. Yeah, absolutely. So that's good feedback. Let's do one more thing. We got a few minutes, and if you have any questions, we'll always take questions at the end too. So feel free to put those into the chat. But let's look at the actual code. This is the actual code on the back end of this running server. And right here is the vulnerable code. It's really these lines. The first thing is this is Node.js for anybody, looking at it and trying to figure out what's going on. And it's really just a function, display the research. If there is a request query called symbol coming in, and we can look at Burp Suite and we can see in the request, the symbol is right here, /employees. So if we have that, we're going to take the URL and the symbol and concatenate it together. So we're just doing string concatenation here. So if I write a little comment, that's something like 127.0.0.1, insert your port number, /employees. That whole string gets concatenated together. And then what happens next with this variable URL? We say, all right, Needle, go get this URL. Needle is just a package. It's an NPM package out there commonly used. There's other HTTP protocol packages. There's different ones, of course, for every code base and everything. But Needle is getting that URL. And at first glance, it doesn't really look like this is server-side request vulnerable code. That's the code that's vulnerable here. It's like 1 to 2 lines, and you can have such brand impact and really just impact to your company. So 1 line of code can be the nail in the coffin at times. Now,
and Noah, the irony is also not lost on me that a list of credentials like that is exactly the type of tool or the list that we pull from the dark web. into Node 0 to try to leverage and create new credentials or guess, passwords and stuff like that.
Yeah, exactly. So I could take that list. I could try to brute force. I could try to log in as people, move around your environment and your infrastructure. So there it is. And then finally, if you're interested, here's all of the URLs. I got my server running. I'm logging every request URL that came in. You can see all of them coming in, just as kind of feedback. If you're wanting to play around or experiment with server-side request forgery, you can, console log or put it in the command line. These are helpful ways. And so you can see, very simple, this is how we did it. All these different ports that we scanned. So in general, that's really all I have from a demo perspective, but it's something to be aware of and everything. Jake or Brad, is there anything else you want to add?
Yeah, I'd add one thing. So you see on line 15 where that mouse is right now, you see const URL.
Yep.
It's taking the URL and the symbol just directly from the user input. There's no whitelisting, there's no sanitization. Anytime you do that as a dev, it's a risk, right? So that's kind of the thing that would be a red flag to me just reading through this is there's no kind of, nothing's protecting the application from malicious user data, right? So there you go, you see Noah's making sure that it would be 127001. And then you could either whitelist it, blacklist it, however the application is supposed to function. From there you can kind of confirm.
Yeah, and the thing to be aware of, like you said earlier, it's not just 127.0.0.1 or localhost. It could be 0.0.0. What was it?
One more zero.
Yep.
Yeah, or so, just zero. Yeah.
Yeah, or zero. So there's a lot of different variations that you also have to check for. Just because I put 127, I didn't put localhost or I didn't put 0. Those are pathways. If we have your code, if we can look at your code, that's just another way for us to figure out how you wrote this, reverse engineer it, find a way in, pull your code down, run it locally, any of those things. So attackers can get creative. They can, if they have your code, I can copy and paste it, set up my own server and see if I can break through it. And then I come back to yours. Is that a common approach you do as well?
Yeah, so my go-to approach for this kind of application would not be a blacklist like this. It would be a whitelist. So, I'd whitelist the particular URL that you're importing if that's how you decide to build it. I'm not saying that's the best way to do it, but, I think, yeah, exactly. Whitelisting it like that is a way better approach. And the reason being, if you were to blacklist using a 127.0 and the zeros you see down there, there's always another bypass. There's always something else the attacker can creatively do to get past that blacklist, right?
Yep.
If you're using a whitelist, there's one option. That's exactly what that'll be.
Yeah, that's a really good point too. Sometimes you have to think about it in the inverse. When developers are programming and everything, you might say, all right, let's block localhost. What about other things? What if I try to go after your EC2 metadata? We didn't even think about that one. What if the developer isn't even aware that it's going to be deployed or it's going to go to an SRE team they're going to deploy on an AWS? There's so many different chains and silos of engineers. It's hard to capture everything to keep out. Why don't we just go after the things that we will let in? So yeah, I like that approach too. And it's usually easier on the developer.
Yeah.
So, yeah. Brad, anything you want to add as well? We got about 5 minutes. If you have a question, feel free to drop it in the chat.
No, I think we covered it pretty extensively, guys.
Yeah. Yeah. Sir, just to recap for anybody, server-side request forgery it might not seem like a lot. You might sometimes wonder what can you do? Okay, it's just a URL. It goes somewhere, it does something. What's the big deal? You can expose a lot of information. You really have to be careful and think about these things as you build applications, enterprise, SMB level applications, no matter what the size of your company is. If you're a big company like Capital One, or if you're a small mom and pop shop, you got to think about security. That's the biggest thing I would at least share with all my developer software engineer friends, always think about each line of code that you add to a code base is another potential foothold, is another weakness in the code. And, larger applications, they have more surface area for us to go after, but we have to, be aware of these things and always train and educate. So yeah, I don't think we have any questions really coming through. Jake, is there anything else you want to kind of close on or just add in general?
Yeah, I think, we covered the topic pretty well, but I would stress again that if, as a developer, if you're going to make a request, or you have to, doing the client-side JavaScript, right? You can avoid a lot of these issues through opting for that route. So that's what I'd recommend.
Yeah, absolutely. And I think with that being said, we're a couple minutes early, but just to give you a little feedback in general, I know in the last Attacker's Journey Tech Talk, this is following my journey of learning cybersecurity, learning to be a hacker and hacking these things and doing them real time and showing you my findings, bringing in experts like Jake, Brad, analyzing it from the business side, the developer side, the hacker side. It really gives us that clarity. An update for me, I know I told people come the next Tech Talk, I would have hacker status on Hack the Box. I finally achieved that. So that was a nice challenge. They keep retiring boxes and pulling points. And so it's always this race. You have to hack so many boxes in a certain amount of time. So we finally got that, Brad. Keep doing the Hack the Box. If anybody in general wants to learn this more and you want to try these things, Hack the Box is really where I started out, and it's really helped me a lot. The next thing that we have queued up for our next Tech Talk is going to be Ntlm Relay. Brad or Jake, anything you want to give us a little quick glimpse on what Ntlm Relay is and why we should care?
Yeah, so I'll preface by saying I'm getting more into the network pen testing side of things. So that's kind of where I'm looking to pivot next year. So it's not as much my, I'd say, area of expertise. I'm still definitely learning, and I'm looking forward to attending the next talk in that area. But from my understanding, you basically can listen on a network, and whenever people log into their computers, and take their session and relay it and pretend to be them and log in. So it's really interesting, and I'm excited for next Tech Talk for sure to hear more about it.
Yeah, absolutely. So if you hear that phrase and you see it come out on the Tech Talk Ntlm Relay, and you're like, what is that? I'm not sure. It's really a way for us, once we're on your server, we're just listening. We're just picking up hashes. We're stealing people's credentials, and then we're going to do something with them. So it's a very bread and butter type attack once you're on the network. And I encourage everybody to come check that one out. We'll be doing that in about a month. Other than that, that's all I have. Thank you, everybody, for joining. If you have any questions, you can always reach out to us on LinkedIn, and we'll always be happy to chat with you. Other than that, y'all have a great Friday, and we'll see you in a month.